Okay, so this is all of the solutions for Quiz 1 for College Algebra for the summer session at CCV in Winooski. All right, so the first question is graph the interval and the number line. And the square brackets means, these brackets right here, means that it includes the number. So this includes -1, it includes 5, and everything in between. So -1 is here on the number line, and so you're just going to put a solid dot. If it had a curved bracket, then you would put around an open dot. And it goes up to 5. And it includes everything between -1 and 5. And as you can see, I struggle with straight lines on this thing. But anyway, that's it. Next one, graph the interval on the number line -4 to infinity. The curved brackets means it goes to that number but does not include that number. The curved bracket is always curved next to infinity because you can never actually get to infinity. So that's the way I always remember it. All right, so -4 is where it starts, and it does not include -4. So I shouldn't have put that little dot, but it does not include -4. And so we're going to put open circle. And then it goes all the way to infinity, which means it starts at -4 and it goes all the way to infinity. So you put an arrow to the right. Okay, this next one goes from -2 to 1, but you just have to figure out what kind of brackets you're going to use. So -2 is not included, so you're going to have a rounded parenthesis, and that's -2, and you put a comma because it's going from -2 up to 1. It does include 1, so you want to put a square bracket. Number 4, it goes from -2 to 1, and it doesn't include either one of them. So that means both of them are going to have rounded brackets or rounded parentheses. So it goes from -2 up to 1, and everything in between, that's what the comma stands for. And neither -2 or 1 are included, so you use rounded parentheses. Okay, this next one, number 5, is wanting you to go from the old notation or the traditional notation of less than or equal to, greater than or equal to interval notation. So -1 is less than x is less than 5 means that x is between -1 and 5, but it does not include -1 and 5. So the way we write that in interval notation is -1 with a rounded parenthesis up to 5, and it does not include either one. If it included it, would say less than or equal to, and it doesn't. All right, so graphing that, we're going to go from -1 up to 5, and it's going to be everything in between. Okay, on this next one, we want to just simplify this and combine all the like terms, and they're all numbers, so this is just an order of operations problem. So 1 times 1 right here is just 1. So we're going to put 1. And then -2 times -3, so these combine here to make 6. So we're going to add 6. And then here we add 3 times 3, which is 9. Plus 9 is going to give us 16. Okay, this next one asks us to simplify the expression and write using positive exponents. So the first thing I generally do with these is deal with what's on the inside of the parentheses before distributing the exponent that's on the outside. So what I see here is I've got these x's that need to be dealt with. So I've got x to the -2 over x. And when x is by itself, it's really x to the 1. We just don't always write it. And what that means using the exponent rules is x to the -2 minus 1. So we subtract an exponent if it's in the denominator and it's got the same base. So that is x to the -3. And what that means is that we've got 1 over x cubed. So the negative in the exponent means it goes to the denominator. So we're going to rewrite this one. And then the other part of it is that we've got y squared over y cubed. And I'll do it all the way through instead of just taking a shortcut. So we've got y squared minus 3, or y to the 2 minus 3, which is y to the minus 1, which is 1 over y. So now we have this 1 over x cubed, and we have 1 over y, which means x and y both end up in the denominator. So let's write that out. All right, so we're still working on the inside. We haven't dealt with the squared on the outside. So we've got 6 on top, and then on the bottom, we've got x cubed, and we've got y to the 1. And the whole thing is still squared. So we have to square every single thing in the entire term, the entire expression. So on the top, we get 6 squared is 36. On the bottom, we get x cubed to the 6th, squared. I'm getting ahead of myself there. X cubed squared means we take x to the 3 times 2. So we multiply when it's a power to a power, and that is x to the 6th. Okay, so we get x to the 6th on the bottom, and then we get y squared, which is pretty straightforward, so I'll just write that down. Okay, so that's our final answer on that one. 36 over x squared. Sorry, 36 over x to the 6th y squared. Okay, number 8 asks us to simplify the expression, and if you look at this, you've got two radicals. They're both square root, which means we can combine everything because it's times. If it was plus, that's a completely different story, which is number 9, so we're going to deal with this one first. So it means that we can put everything underneath the radical together. But right away, I'm going to start looking for some things that I can take square roots of. So here, I see there's a 7. And I recognize right away, and this is where knowing your multiplication facts really well helps things to jump out at you. I know that this is 7 times 5. So now I know I have 2 7s. Okay, so I have a 7 here, and I have a 7 here. When you have 2 of something multiplied together, when you take the square root of it, you just get one of them. That's the way square roots work. So I'm going to rewrite this as 7 times 7 times 5. Okay, so that's the numbers. Now I've got a squared times a. So I'm going to leave the a squared separate from the a because when I take the square root of a square, I know it's going to come out. All right, and then I've got x times x cubed. Well, neither one of those are square rootable easily, so I'm going to put them together. X to the 1 times x to the 3 is x fourth to the 4th. And remember that x to the 4th is just x squared times x squared. That means we have 2 of them. Okay, so when we square root of it, we're going to get one of them. All right, so let's work on this. So every time we see something that's a perfect square, we're going to take it out and square root it. So we get 1 7 that comes out, and we get this a coming out. And when we square root the x to the 4th, we get x squared. And then what's left here, I'll circle, or I'll put a red line under actually. So that's what we have left. So what we have left on the inside then is the 5a. Okay, so that's the final answer on that one. Okay, so the next one asks us to combine the following expressions, and what we see right away is that there is a minus here and there's a plus here. So that means that we're going to have to find common terms, because you can't add or subtract things that aren't common terms. These are not common terms. One is the square root of 180, one's the square root of 80, and one's the square root of 20. We can combine them because they're all square roots, but we do need to find a common term to have underneath the radical sign. And I see that all of these things are factorable. So I'm going to start playing around with some of these numbers. I see 180 could be 18 and 10, and then we've got 9 and 2 and 2 and 5. So look at that. We've got a perfect square here, the 9. We've got a perfect square here, which is the 4. Okay, so that's going to be 9 times 4 is 36. You could also do it that way if you'd like. So that means 180 is 36 times 5. 36 is a perfect square. All right, so let's do 80. So 80 is over here. I'll do it in a different color so you can see that I'm doing something different. 80 is going to be, let's try 8 times 10. 8. And I'm doing this, I'm not grabbing on to the perfect squares right away just because I know not everybody sees them. So I'm going to show you just a way to just start randomly factoring things and finding the perfect squares. So I get 4 and 2, and here I get 2 and 5. So again, I have a couple of perfect squares. This all combines to be 16, which the square root is 4. You can also look at it as here's a 4 and here's a 4, so you get 4 times 4. And so anyway, we've got 16 times 5. So 16 times 5 for that one. And then 20 is going to be 4 times 5. And again, with a perfect square, we've got a 4. All right, so I'm going to go ahead and do that here. So 180, I'm going to say, is 36 times 5. And then 80, I'm going to say minus 80 is, keep the radical sign there, don't get rid of it yet. 80 is 16 times 5. And then 20 is 4 times 5. And look at that, and you may have recognized it before I wrote it down, but every one of these has a 5, which means if we take the perfect square out, we're going to end up with square root of 5, and they'll all have a common term. All right, so the blue one, square root of 36 is 6, square root of 5 stays square root of 5. The red one, square root of 16 is 4, and square root of 5 is 5. And the green one, square root of 4 is 2, and the square root of 5 is 5. So now I just have 6 minus 4 plus 2. So 6 minus 4 is 2 plus 2. So if I lost you there, you're going to take the coefficient in front and you're going to add them or subtract them, just as if this was, imagine that this was 6x minus 4x plus 2x. So the square root of 5 is just a common term that must stay underneath the radical sign. So it's similar to that. Okay, so I'm just putting that in parentheses. And we end up with 6 minus 4 is 2 plus 2 is 4, square root of 5. So that should be your final answer on that one. Okay, the last one we're just supposed to multiply. So this is just multiplication with radicals. I'm just going to use FOIL. I'm going to do the first, the outside, the inside, and the last. So we're just distributing every single term, so you should end up with 4 terms, some of which may combine. All right, so we get square root of x times square root of x, which is just square root of x squared. And then the next term, let's see, I'll do the outside term. So I get plus 1 square root of x, and you don't have to put the 1. The inside terms, which is negative 2 or minus 2 square root of x. And then the last term, which is minus 2 times positive 1, so you get minus 2. Okay, so I see right away a couple of things. One, the square root of x squared is going to, they're inverses of each other, so they'll cancel each other out, and you just get x. All right, the next thing that happens is both of these, like we saw in the last problem, are like terms. So we've got 1 square root of x minus 2 square root of x. So we get minus 1 square root of x, minus 1 square root of x, but you don't have to put the 1, minus 2. So really what most people would write is x minus the square root of x minus 2. Those are all different terms. They're not combinable, so you have to leave it just like that. There's nothing more you can do with it. Okay, thanks.